In this lesson, we're going to explore how to solve quadratic equations, which are essential in algebra for finding values that make polynomial expressions equal to zero. Let's examine this specific quadratic equation, x squared plus 4x minus 7 equals 0. This is a perfect example to demonstrate the quadratic formula. Before we can solve this equation, we need to understand its structure. Every quadratic equation consists of specific terms that we need to identify. The first term is x squared. This is our quadratic term, and it's what makes this equation quadratic rather than linear. Any equation with an x squared term will have exactly two solutions, whether real or complex. Next, we have 4x, which is our linear term. The coefficient 4 affects how the parabola is positioned horizontally. A larger coefficient shifts the axis of symmetry further from the origin. Finally, we have negative 7, our constant term. This value determines where the parabola crosses the y-axis. Since our constant is negative, the parabola will cross the y-axis below the origin. To use the quadratic formula, we need to write our equation in the standard form, ax squared plus bx plus c equals 0. This standard form helps us identify the coefficients we'll need to substitute into the formula. In our equation, a equals 1, which is the coefficient of x squared. Although it's not written explicitly, when no number appears before x squared, the coefficient is understood to be 1. The value of b is 4, which is the coefficient of our linear term x. This middle term will affect both the position and the direction in which the parabola opens. And c equals negative 7, our constant term. The sign of this term is important because it tells us whether the parabola crosses the positive or negative side of the y-axis. So for our quadratic equation, x squared plus 4x minus 7 equals 0, we've identified that a equals 1, b equals 4, and c equals negative 7. These are the exact values we'll substitute into the quadratic formula to find our solutions. With these coefficients clearly identified, we're now ready to apply the quadratic formula. The formula will give us the exact values of x that make this equation equal to 0, which are the points where the corresponding parabola crosses the x-axis. In our previous work, we ended up with the quadratic equation x squared plus 4x minus 7 equals 0. Before solving this, we need to identify the coefficients that will plug into the quadratic formula. To identify these coefficients, we'll compare our specific equation with the standard form of a quadratic equation, ax squared plus bx plus c equals 0. This standard form helps us organize the terms properly. Let's start by identifying the coefficient of x squared, which is the value of a. In any quadratic equation, this coefficient tells us about the opening direction and width of the parabola. In our equation, the x squared term appears as simply x squared, with no visible number in front. This means its coefficient is actually 1, since 1 times x squared is just written as x squared. Next, we need to identify the coefficient of x, which is b in our standard form. This middle term affects where the axis of symmetry of the parabola is located. In our equation, we can see the term plus 4x. This tells us the coefficient of x is 4. The positive sign indicates the parabola's axis of symmetry will be shifted to the left of the y-axis. Finally, we need to identify the constant term, which is c in our standard form. This value affects where the parabola crosses the y-axis. In our equation, we can see the term minus 7. This means our constant term c equals negative 7. The y-intercept of our parabola will be at negative 7 on the y-axis. Now we have identified all three coefficients from our quadratic equation. We've determined that a equals 1, b equals 4, and c equals negative 7. Knowing these coefficients is crucial because they're the exact values we'll substitute into the quadratic formula. The quadratic formula uses these three values to find the x-intercepts of our parabola, which will give us the solutions to our original equation. With a equals 1, b equals 4, and c equals negative 7 identified, we're now ready to apply the quadratic formula to solve our original equation. These coefficients completely determine the shape and position of our quadratic function. The quadratic formula is one of the most powerful tools in algebra, allowing us to find the solutions to any quadratic equation without factoring or completing the square. To use this formula effectively, we need to understand what each part represents and how they connect to our original quadratic equation. The letters a, b, and c come directly from our standard form of a quadratic equation, ax squared plus bx plus c equals 0. The a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. The expression under the square root, b squared minus 4ac, is called the discriminant. It's one of the most important parts of the formula because it tells us about the nature of our solutions. The discriminant is like a detective that reveals how many solutions we'll find. If the discriminant is positive, we'll get two different real solutions, meaning our parabola crosses the x-axis at two distinct points. If it equals 0, we get exactly one real solution. Our parabola just touches the x-axis at its vertex. And if it's negative, we get two complex solutions. Our parabola doesn't intersect the x-axis at all in the real number system. The plus-minus symbol in the formula is what gives us our two potential solutions. When we calculate using the plus sign, we get one x value, and when we use the minus sign, we get the other x value. These two values are the x-coordinates where our parabola crosses the x-axis. The denominator 2a balances the entire expression. The reason we divide by 2a comes from the algebraic manipulations of completing the square to derive this formula. Notice that if a is larger, the solutions get closer together on the x-axis because we're dividing by a larger number. To apply the quadratic formula, we first need to rearrange our quadratic equation to the standard form, ax squared plus bx plus c equals 0. This ensures we can properly identify the coefficients a, b, and c to substitute into our formula. What makes this formula so powerful is that it eliminates the need for factoring or other specialized techniques. No matter how messy the coefficients might be, whether they're fractions, decimals, or even irrational numbers, the quadratic formula will always give you the exact solutions. Many students find it helpful to memorize this formula through a simple song or mnemonic device. The investment in memorizing it will pay off throughout your mathematical journey, as quadratic equations appear in many applications from physics to economics. When solving quadratics using this formula, remember to carefully identify your a, b, and c values first. Calculate the discriminant to understand what type of solutions you'll get, and then substitute everything into the formula. Both the minus and plus versions of the calculation will give you your two solutions. Now that we've found the discriminant value of 44, let's substitute all our values into the quadratic formula. We have negative 4 plus or minus the square root of 44, all divided by 2. To simplify this expression, let's first look at the square root of 44. We can rewrite 44 as 4 times 11, which means the square root of 44 equals the square root of 4 times 11. The square root of 4 is 2, so we get 2 times the square root of 11. Now we can substitute this simplified form back into our quadratic formula. We have negative 4 plus or minus 2 times the square root of 11, all divided by 2. Notice that we can divide both the numerator and denominator by 2, which gives us negative 2 plus or minus the square root of 11. To be absolutely sure our solutions are correct, let's verify them by substituting back into our original quadratic equation. X squared plus 4x minus 7 equals 0. This step is always good practice to check our work. According to our work, we have two solutions, x equals negative 2 plus the square root of 11, and x equals negative 2 minus the square root of 11. Let's verify each one separately. Starting with our first solution, x equals negative 2 plus square root of 11, we'll substitute this value into the original equation to see if we get 0. Let's expand this step by step. For the first term, we need to square negative 2 plus square root of 11. Using the formula for a squared binomial, we get 4 plus 11 minus 4 times the square root of 11. For the second term, we multiply 4 by negative 2 plus square root of 11, giving us -8 plus 4 times the square root of 11. Now we can group all the numerical terms together and all the terms with square root of 11. Notice that the terms with square root of 11 have opposite signs. -4 times square root of 11 and +4 times square root of 11. These will cancel each other out completely. Adding the remaining numerical terms, we have 15 minus 8 minus 7, which equals 0. This confirms that our first solution is correct. Let's verify our second solution. X equals -2 minus square root of 11. Again, we'll substitute this value into our original quadratic equation. Following the same approach, we expand the squared term using the binomial square formula. When we square -2 minus square root of 11, we get 4 plus 11 plus 4 times the square root of 11. Notice this time we get a +4 times square root of 11 because we're multiplying two negative terms. For the second term, we have 4 times -2 minus square root of 11, which gives us -8 minus 4 times the square root of 11. Again, we group the numerical terms and the terms with square root of 11. Just like before, the terms with square root of 11 have opposite signs. +4 times square root of 11 and -4 times square root of 11. These cancel out perfectly. Adding the remaining numerical terms, we again get 15 minus 8 minus 7, which equals 0. This confirms our second solution is also correct. Both values of x satisfy our original equation. We've now verified both solutions. The quadratic equation x squared plus 4x minus 7 equals 0 has two solutions. X equals -2 plus square root of 11 and x equals -2 minus square root of 11. These are exact solutions, though you could use a calculator to get decimal approximations if needed. The key to solving any quadratic equation is to follow a systematic approach. Identify the coefficients, use the quadratic formula, simplify the result, and verify your solutions by substituting back into the original equation.